we're going to be doing something a little bit different this video. I've got the game open right now to show you what we'll be coding over the course of this video and the next one. So let's click on Sandy. And I'm going to click outside. Well, first we get this nice blue and yellow bits and nodes around here. Well, I'm going to click on Sandy. I've got her selected. I'm going to try to move her out here, outside of this little couple of ranges she's got. And she deselects, didn't move, nothing happened. So now I'm going to move Danny, and I'm going to move him somewhere blue. And he reselected, and he's now showing the yellow. I'll move him again. That'll end Danny's turn. Now I'm going to move Sandy all the way to the end of her yellow. There you go. She's used both of her actions on movement. She deselects. It's no longer her turn. Let's click on Sandy again and notice how these movement bubbles sort of deform to conform around these walls, and the rubble is a real impediment. It really slows our characters down and changes how they can move. So, this is the beginning of our foray into pathfinding. The code at work here is a field-stripped and simplified version of something, well, at one point it was A-star, it's not anymore. So A-star, pathfinding, pathing, it's all pretty complicated, and it can be an awful lot of work to comprehend it all. So this video, I'm going to be explaining the code at work here, and I've decided to use some visual aids to help everybody get through it all so we can go into the next video coding all of this with as much understanding and gusto as we can possibly muster. Pathfinding, movement on a grid, it may be complicated, but with a little bit of work and know-how, we can find a solution that fits our need, is relatively efficient, but most of all, it's
mediocre code.
Hey YouTube, I'm Sergeant Indy. Welcome back to my turn-based strategy tutorial for GameMaker Studio. You might notice we've got a different setup for this video. That's because we're going to talk about the basics of pathfinding on a grid. Just a brief overview so that we can code it all next video, since this block of instruction is kind of complex. Last time I tried this video, it was me standing in front of a great big whiteboard wall I've got at home. We had a puppet and everything. It was great. But sound quality was bad, and I just don't have the resources to properly light a whiteboard. You guys know it takes like 4 lights to do that? It's ridiculous. Anyway, instead of GameMaker Studio or my big whiteboard wall at home, we're looking at MS Paint here on the left, and we're looking at OpenOffice on the right. This is seriously high-tech stuff, top of the line. So here's a grid on the left, which you guys can't really see my cursor here because MS Paint's kind of stupid. But anyway, that's a grid. Obviously, you folks are pretty smart. Probably already picked up that that's a grid. This poorly drawn stick figure here, that's where our actor is standing. To the right, I've got a Word document open where I'll be sort of pseudo-coding some basic stuff, some notes that we'll need to make all of this work properly next video. And now I'm going to talk you through a pretty basic pathfinding algorithm, and we're going to call that movement range. So let's go ahead and put this down here. We'll go movement range, some open parentheses, close parentheses. This is the script we're going to be coding next video. So the goal of this movement range function is to step through every single node within movement range and give each node a G-score. So obviously, O node will need a G-score. And we'll obviously be running this movement range every time we click on an actor. It's going to essentially highlight all of the squares in that actor's movement range, right? You guys see what I did there? Pretty clever, huh? So this G-score is going to be a number, integer, and that G-score is essentially how far away it is in movement points from the node that we're starting from. Again, with this little dude with the stick figure here. So now, let's get back into this movement range thing, and let's talk about what arguments we're going to need to pass to it. So obviously, we'll need to pass where we're pathfinding from. So the first argument will be the ID of the origin node, the node that our actor is standing on. So ID of origin node. Great, so that's our first argument. Then we obviously need a movement range. What we're going to do is we're going to give all of our actors a move variables, and that'll be how many squares of movement they have. So let's make a note of that too. So actor will need a move variable. Great. Ultimately, we're also going to be coding a system sort of like how the new XCOM works as far as movement's concerned. So actors will essentially have two actions, one that can be used for movement and the other can be used for either movement or other actiony stuff like making attacks or casting spells or whatever. So our third argument, and also another variable our actor will need, is an actions variable. So what we got here is we're going to pass the ID of our origin node, our move variable from our actor, and our actions variable from our actor. Great. So essentially, move times actions is going to be the total number of squares you can move. If the player wants to move further, they could spend both actions on movement. Pretty simple. I'm stumbling over myself. Sure, all you guys are right on target. 3 arguments, origin node, move, actions. Done. Now, in movement range, we're going to need a few things. This is going to be a big, complicated script. The most important 2 things that we need in there are 2 data structures. So we're going to have open and closed. Right, so closed, this is going to be a DS list. We've worked with lists in the past. Pretty simple, just a big clump of data all sort of cataloged together for easy use. The other data structure, open, that's going to be what's called a priority queue. Priority queue, or what's known in GameMaker as a DS priority. Okay, great. So, where a list is just, again, kind of like a clump of data held together in a data structure, a priority queue is a bit more orderly. When each bit of data is put into a priority queue, it's placed in there with a priority, essentially a number showing its order or its importance. In this case, the bit of data we're storing in open is the instance ID of nodes, and the priority that they'll be put in there is based off of that node's G-score, or how far it is from the source node. That way we can go through it from nearest nodes to furthest nodes and have a bit of order to the big chaos mess that is this chunk of code that we're trying to write. To be a bit more specific, open will be for nodes that we're aware of but haven't gotten to yet. So we're going to put nodes in there to go to later. And then once we've gone through them, we'll put that ID into the closed list. So let's make a couple notes of that. So for nodes we haven't calculated yet, and then closed is for nodes who have been calculated. Great. Okay. So the first thing we're going to need to do in movement range is we're going to need to put our origin node into the open list. So origin node into the open list. The origin node's G-score is obviously 0, so let's do that too. G-score of 0, because obviously the origin node is, well, that's where we're standing. So pretty simple, right? Then we need a big fat while loop, and this is going to get kind of gross. So, in fact, I should probably, let's put this, let's control X this, we'll do things a bit more orderly. So, because obviously we're going to make our 2 data structures, and then we're going to put the origin node into it, and then we're going to have a big fat while loop. So this while is essentially going to be while open is greater than 0, right? So that's while the open list is not empty. We're going to do all of the code in this while loop over and over and over again until we're done. And how about I grab all of this, and we'll go ahead and keep it times, but how about I drop it down to a 10 or maybe even a 9? That'll give me a bit more room to work with trying to keep this all on the same page. So again, while this open list is open, so while there's still things in the open priority queue, we're going to do all of this code. The while loop's first step is to delete the node with the lowest G-score from the open queue. In this case, that's going to be our only node, and we're going to put that into a variable called current. So in here, we're going to do current equals, and it ends up being DS priority delete min, and that'll be the open queue. And I'm not sure if this is the exact right amount of arguments, but the point is, what DS priority delete min does is it takes the thing from open with the lowest priority, deletes it from that priority queue, but when it does that, it returns whatever it was that was there. So in this case, it'll return that node's ID, and store it into our current variable. Great. So now what we need to do is, if you remember those neighbor lists we made in just like the first video, we did those and we modified them a bit in the second video, but we're going to go through that entire neighbor list. We're going to take all of them and we're going to stuff them into the open list. So let's visualize this first real quick. So far, we'll take this and we'll take the fill. So far, we have, well, that's way too, let's Control Z that. I thought I'd switch to a lighter color. There we go. Okay, so far, we've put this node into open. And so we'll have that be green. Let's take a little bit of text in the black again. And let's put its G-score of 0 there. All right, so hopefully everybody can see that. Okay, so this is in our open. That's why it's blue. And it's got its priority of 0. So right now we're deleting it from open. So, well, we'll leave it blue for now because it's going to go somewhere else by the end of this. So now we're going to go through all of current's neighbors. So we're going to go through, I'll just make a note in italic. So go through current's neighbors. And that's essentially going to be done in a big nasty for loop. So we're going to go through all of this node's neighbors. We're going to give them a G-score. And then we're going to put them in the open list. So give them a G-score, put them into open. So let's do this right now. First, we're just going to do the for cardinal and hit F, because F is fill in the the sprite editor of GameMaker. It doesn't work like that here. So boop, dang it. I just clicked that. Why does it keep messing up my colors? Put all of these guys here, and obviously they're 1 away. So they'll be put in there with a priority of 1 and a G-score of 1. Let's see if I can put these all in here at pretty reasonable sizes. There we go. Okay, so we got the 4 cardinal neighbors scored and put into the list. Then, of course, there's our diagonals, because these guys are also neighbors of our first node, right? Well, we're going to do something a little bit different with our diagonals. We're going to have a system sort of like Dungeons & Dragons, where diagonal movement costs a little bit more, 1.5. So essentially, every two squares, so 1, 2, this square will end up costing 3 movement points. It'll make our movement radius a bit more like a circle instead of just a big square or a diamond if you double costed the diagonals. I like the big circle movement. So what we're going to need here is obviously a cost mod, and I didn't mean that. What? Don't autocomplete. Don't you autocomplete on me. Cost mod, and then we need to score diagonals at 1.5 times the G. Okay, close enough. So all of these guys now would also, you guys saw that, right? It switched back to black on me. Why is it doing this? All right, so all of these guys are also going to be in the open list, but they're going to be in there with and it doesn't switch back to black when I want it to. They're going to be in there with 1.5. 1.5, 1.5, and of course 1.5. I almost put a comma, which is, I think that's how they do it in England, so maybe I should have left it. All right, so finally we need to give each of these neighbors a parent, and so that's another thing that our nodes need. They need a parent. What this parent variable will do is it will hold on to the ID of whichever node scored them. So obviously this node is scoring all of these ones. We're going to denote this with just a line drawing. It switched back to black again. Why is it being such a jerk? All right. So we're just essentially going to point back to this one, and that's going to represent our parent. So score diagonals at 1.5 G. And actually, now that I think about it, cost mod, let's Control C all of this. Put it here. Cost mod for diagonals. And then give them a G-score based off cost mod. And then put them into open. Great. Okay, so that's slightly better notes. And then we also need to, obviously, Control I. Well, let's not do that. So parent equals current. There, and that's, again, we're denoting the parentage with these simple red lines for now. Okay, so again, parent will be the current node. It's going to hold the ID of the node, and it's essentially going to point back towards the node that it's taken to get there, the node that scored them. And you'll see how this works out in the long run. When all of this is done, we're finally going to take our current node and we're going to stuff it into the closed list. So, current into closed list. Great. So, when the current goes into the closed list, let's make this a purple, and we're going to hit the fill, and it's going to switch back to black, but it didn't. Why did that? All right, I've got a bunch of Control-Z's to do. Why is this thing being such a pain in the butt? It worked fine. I did it like a kind of a... it's like a sort of dry run of this. All right, there. Now we're back to purple, and we'll get back to the fill tool, and there, okay. Now, this node is in the closed list. So, now that all this is wrapped up, we can go back up to the top of the while loop and do it again, because while, like open, now has stuff in it again, and we can go and delete the min, which will be one of those guys, and do this all again, except it's not quite that simple. So, we have to be a little bit more picky about what makes it into the open queue. Otherwise, when we get to the next node and addressed all of its neighbors, I mean, let's say we start working on this one now, well, look, most of its neighbors are already in the list, and one of its neighbors is in the closed list. That means we're completely done with him, right? And then what if this was, I'm so mad at Paint right now. What if this was a wall? We don't want to add a wall to our pathfinding. You can't go through a wall. You're supposed to go around walls, right? So, obviously, we need a bit more checking in this mess, right? So, and if we had another character like standing here, we wouldn't want to add that node if there's somebody already standing there. So, we need to add a bunch of things to make all of this a bit more picky. So, we're still going to delete current from whatever the list is, no matter what. We're going to have a great big if statement here, right? And I'll just put a if, and we'll open this up. We're just going to make a list of the things that we don't want to happen here. And I need to shrink all this again. In fact, let's shrink these guys up at top the most, because we're pretty much done with them at this point. There we go. And let's get rid of one of these extraneous spaces. Okay, great. So in here, the node needs to be not occupied. It needs to be passable, so it can't be a wall, so no walls. We don't want to add anything to this open list if it's already in the closed list, so not on closed list. And I think that's all of it. So unoccupied, it needs to be passable. Oh, most importantly, it needs to be in range. So needs to be in range! Exclamation point. Now, our maximum range that we're going to, and I'll go put this back up top. So right here, so our range is going to be equal to move times actions. Great. Let's go ahead and get rid of all of this. Okay, so. And again, finally, it needs to not be on the closed list, because these guys, anything that's purple, we are done with. We don't want to be recalculating anything we've already done. And all of this is pretty simple to do in just one big fat if statement, right? We can even check whether something's already in a list with a really basic script that's already built into GameMaker Studio. So, we've got a system for going through all these nodes in a semi-orderly fashion. And now it's set up to only grab the right nodes and carry on till it's done. Alright, so here we have a demonstration of sorts. This is me going through and trying to do what the computer's going to do. And I've got it sped up as fast as my video editing software will do it. All of the blue nodes, again, those are nodes that are on the open list. All of the purple nodes, or pink nodes, or whatever, they're nodes that are on the closed list. So, open list that's nodes that we know of, and we're going to get to their neighbors list eventually. And closed list, we're done with. We're not doing anything else with them ever again. Done. So, as you can see, the red lines obviously still, those indicate parentage. That's where these links are. Those pointing back to their parent, and you can see these pathways forming, right? So the walls were added because I figured it would be interesting to see that as this goes on, if you have enough movement, you'll be able to get around that wall, and you'll see a path starting to emerge in the top right corner now from that one purple list. And I think I make a couple of mistakes here. I don't go quite in perfect order from lowest G-score to highest, but I'm more or less on target, and this is a pretty good visualization of what the computer's doing when we run this script. It's just branching out slowly, a couple of nodes at a time here and there, scoring them, giving them their parents, pointing back to wherever they came from. But this is how this works. This is what's going on here. So once we're out of that big while loop, this thing that's going on, we've only got a few more things to do. We need to destroy the open queue, which you can see at the bottom of the list. Then we need to color code these nodes. And I don't mean blue and purple like they're color coded now. Nodes that you can get into within one action's worth of movement will be aqua color, pretty close to that. And nodes that are further than that would take both your actions and end your turn, they're yellow. So after we're done color coding the nodes, which we'll do with the closed list, we're then going to destroy the closed list. And that's pretty much it. The color coding nodes is going to be done with a script, but that's so simple. It's like 6 lines of code. No need to really go into it here. But this about wraps up our movement range script. So here we are with our finished movement range script. Everything's run. All of the nodes have been gone through. They've all been given a parent. They've all been scored. So, what does this mean? What does this do? What are we looking at? Well, as you can see, like there's little pathways that have kind of formed. And I've got the paint bucket because it's easier to see. Little pathways that kind of formed. You can see you'd have to kind of go like that if you wanted to go around the wall, or maybe even up like that. In fact, let's say you wanted to go here. Well, what do we have? Well, all of our nodes have that parent variable. This parent holds the ID of this node. So if we wanted to make a path, let's get a nice green to do this path. If we wanted to make a path, we could go from here. I'm so mad at this stupid thing. Fine, we'll make that one green. There we go. Okay. The most important thing we've learned from all of this is that don't use paint for anything. This was a pain in the butt. Alright, so if we right-click this guy, we know this one's his parent. So now, oh, okay, well this guy's his parent. Well, this guy, his parent is this guy. This guy, his parent is this guy. His parent, that guy. His parent, that guy. So we've got a path now we can follow with these parent variables. That's the main purpose of what we're doing here, is that we'll be able to build a path out of all of this, and then we could take our dude and have them follow that path to get from here to here. Just whoop, like that. So, that's the point of all of this. That's what we're doing. I hope I provided a good visualization so you can understand what this code is trying to do. And I hope I've described what we're ultimately trying to do with this piece of code once everything's said and done. So next video, we're going to code all of this. The video after that, we're going to code this. And that's where we're headed. I'll include a couple of links below, and you should try checking them out. If you think you're having problems, or if you think you're stuck, or if you think you're not understanding everything particularly well. But I think if you've made it this far, even if you're not completely confident, you should go ahead and try to move on to the next video anyway. I'm sure this will click when we're writing this code together. Anyway, thanks for watching, everybody. Be sure to like, subscribe, or leave a comment, and I'll see you guys next video.